Let's look at a concrete example. Here we take an RS485 and USB adapter to communicate from a computer with Modbus equipment. The computer plays the primary role. Looking at the green part, we see 3 connectors. One is ground, and 2 others make up the RS485 bus called A plus and B minus. To see it working, we'll connect a small oscilloscope to a plus and B minus, and on the computer we launch an application that will communicate with the secondaries on Modbus. We ask it to scan the bus to find equipment to generate traffic. We can see the signals on the oscilloscope. This represents the bits forming the frame. We now connect a temperature sensor to the bus. We find the same A plus and B minus connectors, ground and the plus connector that will be used to electrically power the equipment with 5 volts. On the oscilloscope, we clearly see the request and response. But what does it indicate? We have to read the equipment documentation to know what to do and the data format. The documentation gives us the device address, here one. We also have the registers used, 1 for temperature and 2 for humidity, on 2 bytes, which is the length of a Modbus register. From the PC application, we request to read 2 registers starting from 1. So we'll have in the response the temperature value and humidity value. To know how these values are encoded, we must return to the documentation, which tells us that the temperature is encoded in an integer representation and has been multiplied by 10 to have a precision of 1/10 of a degree. In the first register, we have 0x0d7 in hexadecimal, which corresponds to the temperature. That's 215 in decimal and 20, 1.5 degrees Celsius. We can see in this example that without its PDF file, it's impossible to use the equipment because each manufacturer uses their own register numbers with their own representation of information. And the encoding of values is also specific to them.